We've made it to the final video of part one, lurking versus confounding variables. So our last set of definitions. A lurking variable, this is a variable you did not collect as part of your study that happens to influence the relationship. So we have this example here, which is one that I first heard when I started grad school about shark attacks and ice cream sales. So it turns out that the number of shark attacks and ice cream sales are highly correlated. So I want you to take a moment and think about why this might be the case. Is it because as we eat more and more ice cream, we are more delicious to sharks?
Okay, so which one tasted better?
Steve.
Yeah, the guy.
With Lisa, I only tasted peanut butter and chocolate.
Lisa had just eaten a peanut butter cup.
But with Steve, I tasted something more. It was peanut butter and Snickers.
You're right.
Yeah,
Steve had just eaten Snickers peanut butter squared.
Steve was delicious.
Yeah.
Or is it because all the shark attacks are making us super depressed and so we're eating ice cream to cope? Hopefully neither of those examples seemed plausible. So what is the other possible explanation? So we don't think shark attacks, guys, this is when I get all excited and draw pictures, right? Cause anything to do with, this is gonna be a weird ass ice cream cone. I don't have good colors for ice cream, sorry guys. Cause ice cream, but there's definitely some lurking variable here, right? The time of year, the weather, something like that. That's what's causing an increase in both. When it's nice and sunny outside, we're more likely to go to the beach, get in the water, potentially get attacked by sharks, and we're also more likely to enjoy a sweet treat like an ice cream cone. So that is a lurking variable. This idea that whatever was happening here, whatever we thought was happening, doesn't actually exist, and instead there is some outside unknown variable that we did not collect that is actually influencing what we're seeing. All right, now this is different than a confounding variable. As you can read here, a confounding variable is an additional explanatory variable that also affects the response but wasn't considered. So I have this example here where there was a city where a lot of people were developing lung cancer and they happen to all work in this asbestos mine. And so asbestos definitely seems like something that might be related to lung cancer. So I'm going to do my best job of drawing another ridiculous example. I have no idea what asbestos looks like, so I'm just going to draw it as a blob. So that's asbestos. Asbestos. And then whenever I try to draw lungs, it gets real unfortunate, but we'll still do that. Yep, that's a lung. That's a lung. That doesn't look as bad as it normally does. Lung cancer. So we'll make, I guess, them sad. All right, so this relationship actually does seem like it makes sense, right? But if we read a little bit further in this paragraph, it says, it is also known that because of the stress they're exposed to, they tend to smoke more. And we definitely know that smoking, gosh, I don't even know what a cigarette looks like. This is sad, huh? Or not sad because it's good, I guess. There's something else that also influences lung cancer that they didn't bother to take into account. So now the issue here is that if you were coming up with numbers, you may say someone that works in the asbestos mine is 2 times more likely to develop lung cancer due to them working in the asbestos mine, but really it might be that they're 1.5 times more likely, and the smoking also makes them 1.5. You know what I'm saying? So you're not able to figure out how much is due to the asbestos and how much is due to the smoking because you didn't take the smoking into account, and you're going to overweight how much the asbestos matters. So our confounding variable is actually just an additional explanatory variable. So that's sort of the relationship we're looking at.